right, welcome to the first quick lesson for Special Topics 2020. First thing we're going to talk about are calipers and their abilities. There's different types of calipers out there. There are specialized ones that might be used for measuring measuring brake rotors, measuring their thicknesses, and those have similar capabilities, although they do have their caveat because the frames are different and they're a little bit more flexible. But we're going to talk about these three right here. So in general, the calipers, they have a general a capability. And that capability is, when I'm talking about resolution, is the ability to measure down to 1/1000th of an inch. So we've got two types of calipers here. We have this really large one here, and then we have this one here. This is a Vernier style caliper, and this one is a dial style of calipers. These are both capable of measuring in the 1/1000th of an inch resolution, meaning that's the smallest amount or the farthest to the right that these two devices are capable of measuring. This one is capable of measuring 1/1000th of an inch over 6 inches. This one here is actually capable of measuring 1/1000th of an inch across 48 inches if calibrated properly. Then we have this style here, which is a digital style caliper, and digital style calipers are in most cases are capable of measuring 1/2 thousandths. So that means we're going from 1/1000th of an inch to these that are able to measure half of that. So they have twice the resolution that both of these do. So it can measure further from the right, further to the right of the decimal on our number, and then also go down to 1/2 thousandths of an inch. So it goes down to 5/10,000ths of an inch resolution. Now, all three of these are really good tools. They do have their pluses and minuses. The Vernier calipers here, the only moving parts that they have are the jaw. Notice on this one here, if it comes up in a picture, it's got a scale that's actually got 2 screws in it. So this one is actually calibration possible in the field if necessary, where you actually set it up on something called a ring gauge, and you set this scale, and it's actually a Vernier style scale. And these are probably the most durable. You can drop them, and they're easily calibratable. Then we go to the dial calipers. These are probably the most fragile of the three here. Dial calipers have very small movements in them. They have really small gears. They have a clock hand that spins around this thing, and it moves at a pretty quick rate. So you can also, this one here has been dropped. So the gear that runs along this rack inside the dial caliper body here, there's a gear inside this mechanism that runs along that rack. Well, that gear is either stripped or its shaft is bent, and that has basically turned this into a really nice pair of dividers. So I can transfer measurements, I can scratch measurements into something, but I can't actually take a physical measurement with these here because they've been dropped just one time. Now they are cheap. I think these came from Harbor Freight. I'll say they're probably $19, which is a steal because they're not bad, of course, until you drop them. Now the other style here, which is the electronic style caliper, the electronic ones can be very durable. Of course, you do have to spend the money to get durable ones. And I would not recommend the ones from Harbor Freight. They're not very good. They do not last very long. And for electronic calipers, you're going to be spending probably minimum of about $50 to $60 and up. If you want to spend a couple $100, you can. Now the nice thing about these here, if I remember right, they were like the $70 to $80 range. These are actually IP67. That means they can get submerged in liquids. Now that doesn't necessarily mean it can be submerged in gasoline. It's a different type of liquid from what they check it with, but they can get wet and they'll still operate perfectly fine. The electronic calipers don't have any moving pieces like in a dial caliper, they actually have what's called a read head, and this read head is looking at a scale that's embedded in this sticker. So when this thing is off now, I don't need to turn it on, I just need to open it up and it's automatically works like it's supposed to. It has different functions, like these two over here are limited to inch only. If I wanted to be able to measure in fractions, I don't know why you would, but it does have the capability of measuring fractions, and also can easily transfer over into millimeters. And this one is capable of measuring in 1/100th of a millimeter, which is the equivalent of 4/10,000ths of an inch. So let's go back to inch because that's the one that we're used to. Those are the three styles. So we have our vernier style, a dial caliper, and the electronic. We go, probably cheapest is going to be the dial style that's just manufactured more. They just tend to be more popular. Vernier style would probably be the next one up. And then, of course, the electronic calipers. The companies that you can go for if you're looking to buy some, like these are made by Shars, and they're actually really good. I took a try on them, and I've been very, very happy with them. Other manufacturers are Mitutoyo, and Silvac is another company. I believe they're from Europe. And they're pretty good, but those are the companies that I would go for. Another one is Starrett too. They're really good, but they're pretty pricey also. All right, so we talked about the different types. Now the versatility of these calipers, it really comes into how they're designed. And what I'll do is I'm just going to focus in on the digital because the bodies are almost all exactly the same. But we're going to point out the different components of the caliper. So of course, we have a dial on the dial style, and then this one has a readout, and then we get into various other components. We have a thumb lock right here. Sorry, it's a locking thumb screw, and then we have a thumb wheel. So our digital readout, of course, we have function buttons, our locking screw, and then our thumb wheel. And then we get into the actual measuring components. Along the length of it, that's called the beam. Then we have our external measuring faces. So when I open this up, we have a measuring face here and a measuring face here. Now it does end out into blades. Now what these allow it to do is to measure, say, grooves inside a shaft, like on a valve here. If I wanted to measure the diameter inside the groove of this, these blade sections on this dial caliper, or these calipers, can actually go into that and measure down at the root of the groove. So we have our external measuring faces, our tapered down blades here. Then we have our internal measuring faces right here. So you can see when we close this off, it closes off like that, and it goes down to 0. So as I open this thing up, it'll open up into an inside diameter. So let me zoom in a little bit. Okay, so let's go ahead and do a quick review. We've got our lock screw, our thumb wheel, the readout or the display, and then our function buttons. We have our external measuring faces here and here, our internal measuring faces here and here. Now coming out the end of this caliper, if you'll see this rod out the end is a measuring device. It's a measuring stylus, and this is called the depth rod. And the depth rod is used from this reference face to the end of the depth rod. So if you need to measure something, a hole that has some specific depth, you can actually use the bottom of this caliper to the bottom of this depth rod. So we have 3 measurement devices on this one thing. We can measure the outside diameter of the length of something. We can measure the inside diameter using these jaws here, and then we can measure the depth of something. Now we can measure step heights with this end here, but there is another way to measure step height, and the way that that's done is actually on the top side of the calipers. Now when they manufacture these, they're actually ground on all faces, and when they're done grinding, they grind along the end of the calipers here, And you can see as I lower or open the jaws, we see this face drops down from the top of the caliper. So the stationary caliper jaw stays still, obviously, and then our movable caliper jaw drops down, but this datum point right here also drops. So if I want to measure the step height of something, I can set this down against a nice flat surface. Let's say we want to measure step height of something, we can put it down against a nice flat surface, and we can measure the step height of something that's protruding off of that surface there. So these are really, really versatile devices. The readout, the lock screw, the thumb wheel, external jaws, internal jaws, the depth rod, and then our step faces or step measuring faces. So let's go ahead and do a demonstration of a couple of these measurements. Now the simplest and the most common use of calipers is just to measure the diameter of something. So if we've got a component that's round, or it could be a component that's some other shape, in most cases for us it's going to be round. I want to measure the diameter of this shaft. I'm just going to use this thumb wheel. Okay, I'm going to use the thumb wheel, and I'm going to draw it up against, and not pressure it, but I'm just drawing it up until it stops. And then I can get my measurement. There we go, 0.3135. So it's 0.3135 diameter. And if I wanted to measure and rotate this at 90 degrees, I back it off, I rotate the shaft or the stem at 90 degrees, and I measure it again, and I get 0.3135 again. And I measure it, and I get 0.3135. Because, well, hold on, there we go. There we go, 0.3135. Repeatability is very important. So that's something that we need to be able to practice. So we did the outside diameter measurement. Now let's go ahead and do a measurement inside the groove here. So I'm measuring this, and the inside of the groove, oh, there we go. The inside of the groove is 0.2475. I'm going to measure the next one down. And it should be about the same, 0.2450. Let me go back up to the top one and see if it's a little different. Okay, 0.2455. We're off by half a thousandths now. 2.450. And then looks like we're getting a bit of a taper on this one. No, there we go, 0.245. Okay, so we've got outside diameter. We can measure the inside of a groove with the tapered blades. Now if we want to measure the length of something, so I want to know how long this block is from one end to the other, I can just open the jaws up enough and then measure the length of this block, and it comes out to 0.299. Actually, hold on, there we go. 0.299 to 3 inches. So nominally this is a 3-inch block. So if we're having a deviation of half a thousandths, that's really not too bad. When I want to measure the width of the block here, we have 2 inches. And then how about the thickness of the block? We measure it at 0.9995. Okay, so we can do those measurements. Now I want to measure the inside diameter of a component. I have this ring here, and I'm going to use the inside jaws. I'm going to open it up, and now this requires a little bit of movement, so I'm going to keep one jaw stationary, and then the other jaw, I'm going to sweep it slightly inside the bore, and I'm going to feel tension on the thumb screw, and I'm going to feel tension on the jaws, okay, until I get the largest measurement possible, and that's going to be 1.1280. And then we can measure the inside diameter of that. Do another one, inside diameter of this component. Same thing, I'm just kind of wiggling one end up and down, and I'm getting 1.3875. Measuring the inside diameter of that. And if I needed to, I can measure the outside diameter. All right, so to measure the height of something, or the step height, we're going to place this tool. See if I can get it like that. Let me just kind of hold it at an angle there. So we're going to place the tool down against the surface. Now the reason they make the end of the calipers, they actually grind them very, very perpendicular and very, very flat. So I've got these two surfaces, and I want to measure the step height from the base of this one up to the top of that one. So I'm going to use the calipers. I have to hold this. There we go. And I'm going to take, of course my fingers are in the way now. Try this a different way. Alright, so we're set up to measure the step height of this block. So what I'm going to do is drop that stationary jaw all the way down against this block. And because it's ground nice and perpendicular on the end, if I rock it, I can feel it when it sits and it stops on that flat surface. And then this one here, I can also push it up against the block, and then I'm going to lower that down against that gauge face, and we see that we come up with 3 inches on it. And you know, that was the same measurement as the length measurement that we got earlier. So that's a step measurement. Now to measure out the to measure the depth of something, using the depth rod, we can drop this down inside there, and then I'm going to extend that depth rod some. And you can see that this surface here, it's being held up off the top of the block. There we go, and we just drop that down against it, and we should be getting about the same. So yeah, we're getting right at 3.0, well, of course it just moved, it was 3.0005. So we've gotten, you know, 3 measurements, all saying that this thing is a length of 3 inches. Okay, so we've talked about the normal outside diameter measurements that we're capable of doing with these, and it was all pretty simple stuff, but there's not many other measurement tools that you can do all these different dimensions with and still have a resolution of 1/1000th or a resolution of 0.5 of an inch. You can say, okay, well, what about a ruler? Well, rulers in most, the lowest resolution you can get on one of those is 1/100th of an inch. Or micrometer. Well, micrometer, 1 micrometer, if it's an external micrometer, it's only capable of measuring external dimensions, so outside diameter or length. This one can do all those measurements within a pretty good resolution. So talking about the next thing, which is going to be measurement practices. So the feel of the tool. You do not want to grab onto a tool, put it onto the part, and squeeze it down until you get the measurement you want. You're supposed to, just using this thumb screw, you're going to bring it down until you feel it travel no more. Now you're going to have to wiggle this piece in the end, the part that you're trying to measure. So let me put it in there. I'm going to put it in at an angle, okay? So I'm going to have it at an angle, an extreme angle. And let's say we measure it and we're getting, it looks about 0.005. We're just looking at the scale there, if you can see that. Yeah, so we're getting, you know, somewhere around 0.005. Well, let me straighten this up and let's see what the difference is. And now we're getting about 95,000. So we had a difference of 0.010 of an inch simply because I have this positioned in the tool wrong. Now, if I bear down on it too hard, let me straighten it up, and I'm just going to bear down on it way too hard. Of course, I picked the wrong ones because I'm not going to bear down on the good ones. I'm going to get a different measurement. So using the thumb wheel and feel and practice, you're going to measure something and get the feel, and you're going to maintain this pressure over here. Now you're not going to screw it down and then lock it. This locking right here is usually for layout purposes or for transferring measurements, and that's not normally something that we're going to do in the automotive field. Alright, so the feel of the tool is really important. You don't want to bear down on the thumb wheel. You don't want to crank it until you get the number you want. You're trying to get a number. Now that number needs to be repeatable. If you make the measurement, you take the measurement, you should be able to pull the part out of it, put it back in, and get exactly the same measurement. So let's go ahead and do that. So I put it in there, I've got the feel, I'm wiggling it, I'm trying to get it to get the jaws closer together. I don't have a lot of pressure on the thumb wheel, and we're coming out to 1.680. Now to make this easier, I'm going to zero this, There we go. I should be able to pull it out, put it back in, and get 0 again. There we go, back to 0. And if I'm capable of doing this multiple times, that means I'm starting to get the feel of this. Now I'm putting this in the same orientation. If I were to turn this ring, say 90 degrees, I might get a different measurement, but it looks like it was made pretty well. Good going, Egypt. So we can get that same measurement. Now notice I did change the 0 point. To do this, to put it back to the regular 0, you just have to close it, and you're going to push the 0 button again, hold it, and it'll go back to 0 again. Open it and close it, you should get 0 again. And that's how you calibrate them. Do a field calibration. So 1.6805 and again 1.6805. So a good practice or a good habit is to take the measurement twice. So you're going to do the measurement 2 times. If the measurement's the same on the second measurement, more than likely that is a valid and precise measurement. Not accurate, but precise. Okay? Perpendicularity. If we're trying to measure the depth or the height of something, we need to make sure that this face isn't sitting on the other face at an angle. Because then we're not measuring the true depth of the hole or the true height of the step. We're measuring an angle off of it, and it's going to increase the measurement. So to get perpendicularity, if we're using the step faces, you can feel it. You can actually feel it in both directions, this direction and in this direction. So you get it in this direction first and you can feel it, and then if you rock it this way, you'll actually feel it seat. Meaning, as I rock it, you're going to feel it stop right there in the middle where that face has met the other surface. Now, on the depth rod side, perpendicularity is a lot more difficult. If possible, you want to be able to rest the ends of the beam down against some surface. So if I'm measuring the depth of a hole, maybe I should be able to put this down in the hole and then do the same thing. I can rock it slightly like this, and then, you know, ideally once this is seated against that surface, that means that this rod is now shooting straight down that hole. Not in the center, but it is going straight down parallel to the axis of the hole or the cylinder that you're trying to measure. Now when measuring ODs, I demonstrated this earlier, you want to try and get the full diameter. Okay? If we were to measure the diameter of this piston, if I had my calipers off to one side, you know, obviously if I had this thing angled, let me try and get that, there we go, maybe that'll work. Oh, how about this? If I had these calipers angled like that, I would not get a true diameter measurement. I need to make sure that I'm going straight across from one side to the other, and I'm measuring the smallest measurement possible. Okay, so it looks like it's 3.1 or 3.9175, and that's the correct measurement. So that's everything with calipers. Again, like I said, this comes with practice, and you know, to get good calipers, like I said, this company here, Shars, is a good brand. These are the Shars Aventors. Yeah, they are made overseas, but you know, I was really happy with them. There's Mitutoyo, if you ever find some good used Mitutoyo Digimatics, those are really good. And as always, you know, a set of dial calipers are always a good place to start, but you do have to be pretty careful with them. One, you know, granted they're not very expensive, but your time to go get new ones tends to be an issue, and we don't want to, you know, waste time. So, I guess if there's any questions, just post them down in the comments or in the team system, and we'll address them there. So until next time, I'll see you later.